Global warming is driven by a buildup of carbon dioxide in the atmosphere. For the past century, our oceans and ecosystems on land have been able to take up some of the excess carbon dioxide. But man can't be saved by Mother Nature indefinitely. The concentration of carbon dioxide in the Earth's atmosphere has increased by about 40% since the Industrial Revolution, and it continues to rise. This is mainly driven by human activities such as the burning of fossil fuels for energy. Temperatures have already increased globally, and climate experts warn that further global warming may take place at an accelerated rate. A concerted international effort is needed to mitigate the magnitude of future climate change, but countries also need to plan for ways to adapt to the impacts of future changes. Experts use global climate models to project future climate change, but these are of two-course spatial resolution to inform climate change adaptation strategies at a regional scale. This is why the CSIR has developed extensive capacity in regional climate modeling over Africa.
Regional climate models are based on the same physical laws as global climate models, but they are applied over specific areas of interest at very high spatial resolutions in order to obtain detailed projections of future climate change that can be directly applied in climate change impact studies. The application of this technology relies strongly on the supercomputing capacity provided to CSIR climate modelers by the Center for High Performance Computing of the CSIR's Maraka Institute. Over the last century, the global average surface temperature has increased by about 0.8 degrees Celsius. However, during the same period, surface temperatures over the southern African region have increased at a rate of about 2 degrees Celsius per century. That is, over the southern African region, temperatures are increasing at about twice the global rate of increase. It means that even if the United Nations Framework Convention on Climate Change processes are successful in keeping the global increase in surface temperature below 2 degrees Celsius, the southern African region may still experience temperature increases as high as 4 degrees Celsius. And such drastic increases in the regional temperatures may be expected to have a wide range of impacts across many different sectors. We can start by thinking about impacts on the agricultural sector. In southern Africa, the maize crop is extremely important for our food security, but the maize crop is also highly sensitive to extreme temperature events such as heat waves. So, in a future climate where regional temperatures have increased by 4 degrees Celsius or more, possibly even reaching 6 degrees Celsius or more, we can expect drastic reductions in maize crop yield over the southern African region, and this may impact in a pronounced way on the food security of the region. In the case of tomatoes, it may become possible to grow this crop over the high-veld regions of South Africa, which under our present-day climate is too cool in wintertime with frost events to allow the production of tomatoes. On the other hand, in the eastern parts of the country of Mpumalanga and Limpopo, it may become too hot under climate change to grow tomatoes during the mid and late summer. The potato crop is another interesting case. Crop models are projected increases in potato crop yield in South Africa due to the increase in carbon dioxide concentrations in the atmosphere, provided that sufficient water is available for the irrigation of the potato crop. All large mammals, including cattle, are of course vulnerable to extreme temperature events, and their food intake, weight gain and mortality most likely be negatively affected by the increased occurrence of heat waves over the southern African region. CSIR researchers are therefore also investigating whether some indigenous breeds of cattle will be more resistant to these future increases in temperature. South Africa's biodiversity are also vulnerable to potential future impacts of climate change. The region that is regarded as a real climate change hotspot is the fynbos region of the southwestern Cape of South Africa. Fynbos is a vegetation regime that has become adapted to cool and wet winters over thousands of years. As the climate system is moving towards a much warmer state, and in the case of the southwestern Cape also a much drier state, we may expect a range of impacts on the fynbos biome. Perhaps the most significant climate change related impact on the fynbos biome is the more frequent occurrence of fynbos fires under a future climate that is much warmer and also drier. The CSIR and Eskom's Sustainability Department are also investigating how climate change may impact on Eskom operations in South Africa. The household demand for energy is likely to decrease in wintertime over South Africa because of winter temperatures becoming higher and higher under climate change. On the other hand, the summer demand for energy is likely to increase as our cooling needs are increasing under a changing climate.
In future, the infrastructure of Eskom and other industries may also be more vulnerable to the impact of extreme weather events such as intense thunderstorms, large-scale flooding, hailstorms, and heat waves. This is why the CSIR and Eskom are formally collaborating to timely project such impacts. The insurance industry, disaster planners, and many other sectors can also use the CSIR's downscaled climate models to inform their climate change adaptation strategies at a regional level.